Quinn's friend here is concerned about her friend's well-being after her perception of calculus changed. They called me to correct their mistakes. So, how did this all happen?
Well, it all started about 2 months ago when we were learning about limits in calculus.
And the teacher wasn't aware of this at all?
The teacher was aware and tried to help them, but also teach the curriculum at the same time, even though Quinn wasn't understanding the concepts.
Clearly, there seems to be some sort of a disconnect between the teacher and the student in this case. Thank you for sharing this with us, Dolphin. I think it's time for us to hear Quinn's side of the story. Quinn, you come up here, please. Thank you.
I heard y'all talking about me. Y'all don't understand me.
Quinn, we're just here to help you.
Now, Quinn, why don't you tell us a little bit about how you feel about this situation?
Well, you see, how I see it, I say that I'm correct and everyone else is crazy. You think I'm crazy? Y'all are crazy.
Quinn, can you tell us what makes a function continuous then?
Well, you see, of course, obviously. So when I look at a function, I know it's continuous just by looking at it. If I can run my pencil while I'm drawing it and I don't have to pick up my pencil, it's continuous. Simple as that.
Are you sure about that?
Yeah, I am.
So, you seem pretty confident in your ability to identify a continuous function. Alright, let's pull up some examples.
Alright, bet. Let's go.
Does this photograph here look like a continuous function?
Yes.
And this one's a challenge here. Does this one look like a continuous function?
Yeah.
Now, Quinn, the second photograph that I've shown you is indeed not a continuous function.
WDYM.
I'm gonna try to show you in the second photograph. You understand that for a function to be continuous, that f0 must exist, and that the function right before it, as well as right after it, must share the same value. One of these things in this graph is indeed not true.
I don't get it.
What needs to happen is that f0 has to equal 1. f0 does not exist at 1. It exists at 2. So you see how there's a disconnect. This doesn't correlate here.
I don't think so. No.
Your mistake here. The function does approach 1 at both sides. But at f equals 0, the equation is indeed non-differentiable. Which means that's why there's a hole there. And the value at f equals 0 is actually 2.
Whatever.
We'll be right back.
Have you recently had to visit the hospital due to an accident? Have you or a loved one been injured and haven't gotten the justice you deserve? Hi, I'm Int, and this is Tanius from the Instantaneous Law Firm. We can help you if you were in a car accident and it wasn't your fault. By finding the instantaneous speed of the vehicle you collided with, we can prove if they were going over the speed limit at the time of your accident. Say your accident happened 6 seconds after you stopped at a stop sign. Say the equation for the velocity of the vehicle is 16t squared, and t represents time. We can then find the average speed of the vehicle at t equals 0 and t equals 6. Using the average speed, we can find the instantaneous speed at 6 seconds and determine if they were in the wrong. Don't be shy. Come on down to the Instantaneous Law Firm and get the justice you deserve.
Welcome back to the show. After discussing continuous functions, do you think we could start talking about IVT?
So, well, the function must be continuous on the closed interval from a to b and differentiable on the open interval from a to b. And so from there, we can use the formula f of b minus f of a over b minus a equals f prime of c.
Quinn, you do realize that what you just described to me was not IVT, but otherwise something known as MVT.
MTV?
Now, you understand what you just described to me was MVT. IVT means that a function is continuous, meaning that it meets all values from f of a to f of b.
Whatever you say, buddy.
It looks like I can't get through to you.
Tell me about it.
Let me explain this in a way that you might understand.
Try me.
Let's say when you were 7 years old, you were 4 feet tall. Now, in your young womanhood, you are approximately, let's just say, 5 foot 4 inches.
Well, actually, I was like 4'6" when I was like 7. So.
Now, when you went from 4 foot to 5 foot 4, you had to grow through all measurements in between, right?
You know, now that you say it that way, I probably was maybe like 5'4" when I was 9.
Good. We are making progress. Stay tuned for the finale. We'll be right back.
CalcBops 9 is the newest and the truest CalcBops album yet, with 6 new bops for all the calcu lovers out there. It's all about the properties of limits. We got one for the sum rule, the product rule, the quotient rule, you name it. Take a listen to the latest tips. The limit of the difference of two functions is the difference of the limits. The limit of a constant times a function is the constant times the limit of the functions. The limit of a function raised to an exponent is equal to the limit raised to the same exponent as x approaches c for that function. Buy CalcBops 9 today.
Welcome back to the show. During the break, I had a longer talk with Quinn about some other topics about calculus. But we've heard a lot from Quinn's side. I want to get back to Dolphin over here. How do you feel like this is going so far?
I think it's good progress, going up the slope.
So over the break, it's come to my attention that Quinn isn't familiar with what an asymptote is.
Why are you making words up?
An asymptote is when a function, let's take this paper for example, let's say a parabolic one. Let's go straight up like that. Is when the function never touches a specific line. So like this one, if you had 2 lines at each side, each one would go to infinity. And it would never cross the x-axis where my hand is.
How?
The asymptote that I just demonstrated is not the only asymptote in existence. There are many forms of asymptotes, some being horizontal, others are vertical, some of them maybe even at a slant. Let's take, for example, the function 1 over x. You are familiar with this function? Alright, as all should be. Very good. The limit to infinity, as well as negative infinity, of that function. Can you tell me what that is? Well, it's 1 over x. So you replace the x with infinity. You basically got one small number over a really, really big number. That makes it 0 for both positive and negative infinity. So we have a horizontal asymptote at y equals 0. To find a vertical asymptote, you look at the function and you try to find the 0 in the denominator. Let's take that function 1 over x for the same example. What are the zeros in the denominator of the function 1 over x? 0. So, that means that 0, x equals 0, will be the vertical asymptote in that function.
Yeah, whatever. And all this is fake anyways.
I assure you, math is very, very real. It should be taken very seriously.
You know what? I'm done here. I think it's time for me to leave. Peace out.
No, please quit. Sit down. Alright, thank you for contacting us, Stallfed. We'll get your friend some help very soon. In fact, we're gonna send Quinn off to Mathnasium, where she's gonna learn all about functions, asymptotes, and other limits of integration. Everything she needs to know about calculus and life. Tune in next week on Dr. Phil, where we have a woman who believes that her husband is indeed involved in a washer method scam. We'll hear all about that next week on the show.